Okay, I got a request to do the lesson on 7.3, completing the square. So before I taught completing the square, we did this sort of remember what we know exercise where we came back and looked at some things. So first we want to start by identifying what is x plus 5 squared. So that is x plus 5 times x plus 5. And then when you expand this, you're going to multiply the first terms and then multiply the first term by the last term. So we've got 5x. Then we're going to multiply this term 5 times each of the terms in the other parentheses. So 5x and then 5 times 5, that's 25. Here we have like terms, so we'll combine those and get x squared plus 10x plus 25. So before we move forward, I just want to draw attention to the fact that this 5 becomes 10 and squared 25. So 5 times 2 is 10, 5 times itself is 25. Okay, let's see if this one does the same thing. So we'll expand x minus 5 times x minus 5, and we'll have x times x is x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, and negative 5 times negative 5 is positive 25. When we combine like terms, we'll have x squared minus 10x plus 25. Okay, again, negative 5 times 2 becomes negative 10. Negative 5 squared becomes 25. As we do this last one, without actually writing it out to expand, I wonder if you can, based on the pattern, see what the last one should be. So in both cases, we started with x squared, and then we doubled this thing to get the middle term, so 16x, and for the last term, we squared it, so we took 8 times itself to get 64. Okay. Then we're going to head in the backwards direction. So in this case, I'm thinking I need two numbers that multiply together to give me 9, but when I add those numbers, I get negative 6. And those two are the same number. It's negative 3 times negative 3 will give me 9. Negative 3 plus negative 3 will give me negative 6x. So this in the different direction. And we can write it like this, x minus 3 squared. Okay, so we factor this one. I'm looking for two numbers that when I multiply together give me 25, but when I add them I get negative 10. Those two numbers are negative 5 and negative 5. So when I list my factors, it looks like x minus 5 and x minus 5, or I could say x minus 5 squared. Okay, based on the pattern, can we just jump to this last part on the final one? So see how I'm taking 5 is half of the negative 10, and it's the square root of 25. So in this one, the factor is going to be half of 14, which is also the square root of 49. As far as whether it's positive or negative, it's based on this middle term. Okay? It's always going to match what we had there. And I think up above it does the same thing. Positive, positive, negative, negative. But the final term, in all cases, is always going to be positive. That's because we're either doing negative times negative, which is positive, or positive times positive, which is positive. Okay. Then what I had students do was to find C and then build a factor. And the C that we want is so that I can make this into a something squared. Okay, it's really nice when the B value is even, because I can just take that in half, and I'd have x plus 3 times x plus 3. If I multiply that out, let's have a look at this. We would have x squared plus 3x plus 3x. And what would that final thing be? 3 times 3, that would be 9. Now when I combine these, we'll see that we get x squared plus 6x plus 9. Okay, so I'm on my way. This almost equals this whole thing. I just need to put a 9 where the C is. So I'm going to say plus 9 in that spot, and then I've got it. So to find this number, I'm taking half of 6. That gives me 3. And then if I square 3, 3 times 3, then I get the final number, 9. Let's try it on the next one. We have x squared minus 8x. So as I'm building the factor, do you know what number should go in here? It's going to be half of negative 8. So negative 4. That's the factor I want to build. And the only way to make this expression equivalent to this is if I add something in this place. And the thing that I want to add is negative 4 squared, or even just 4 squared. Either way, I'm going to get positive 16. Let's do one more. Okay, do you know what the factor is going to be this time? It's 10, right? Because we're doing half of 20. Now, do you know what value is going to go in the spot where C was? It's going to be 10 times 10, or 100. Okay. And then I asked students to describe that a little bit, and then we didn't worry about the last one. Okay, let's head over to the 7-3 notes. On these first two problems, and we don't generally see problems like this, they already have a perfect square trinomial. So this one already by itself equals x plus 7 squared. See how 7 is half of 14 and 7 squared is 49. All of those pieces fit, equals 4, right? This one, they've already built it, so I'm not going to move things around. In this case, do you know what the factor would be? Half of this, so x minus 3 equals 20, and then we could go on and solve it. Maybe we'll come back and do that in a minute. Usually, they're not already set up like that. Pretty typically, and here's the steps, rewrite as quadratic term plus linear term equals constant. You complete the square by taking half of b. I usually right then put it in my factor. Then you're going to square that, whatever that number is, square that and add it to both sides of the equation. Simplify and solve. So let's try an example like this. We're going to start by moving the 56 to the other side of the equation. So we'll have x squared minus 18x, I leave some space, equals negative 56. We want to build a perfect square factor here. I'm looking at this negative 18, I want half of that. So negative 18 divided by 2, that's going to give me 9. So we have x minus 9. Now, in order for this expression to equal this expression, so this whole line to equal this whole thing, I need to add something to it. I need to add 9 squared, right? Because if I multiply this out, remember x minus 9 times x minus 9, the final thing that I get comes from multiplying those two together. That's going to be our 81. If I add 81 to one side of an equation, I have to add it to the other side as well to make the equation still true. So then we have negative 56 plus 81. And that equals, whoops, I didn't do negative. Negative 56 plus 81, that equals 25. Okay, we haven't quite solved it yet, but I just want to practice this part of it a few more times, then we'll come back and take care of those. Okay, if the A, well, first off, we've got some stuff that's out of alignment, right? We want to move the 16x over here, and we want to move the constant over. The way that we can move these, mathematically speaking, is by subtracting it from both sides. So I'm doing the opposite of what it said. Here we had positive 76, I subtract 76, so that part goes to 0. Positive 16 minus 16, that part goes to 0. So my new equation will look like 4x squared minus 16x equals negative 76. Before we can complete the square, we need a, whatever's in front of x to the second power, we need a to be 1. So I'm going to divide every single term by 4. We'll have x squared minus 4x equals, let's see, negative 76 divided by 4, That's going to be negative 19. Okay, now I can build that perfect square factor. So x, what's going to go in here? Half of negative 4. So x minus 2. Then I need to add something here and here to make this equation true. So the next part will fit. So I'm going to square 2. 2 to the second power is 4. I will add that there, and I'll add it here. Okay, we're on our way. All right, let's go back and solve these that we've had. Now that we have, so I'm back up to example 1. Now that we have quantity squared equals number, at this point we can solve the equation by taking the square root of both sides. The square root and the second power, those cancel each other out. So on the left, I'm left with x plus 7. On the right side of the equation, I have plus or minus whatever the square root of 4 is. That's going to be 2. At this point, since the radical is totally gone over here, I suggest writing it in 2 ways. You want to write x plus 7 equals positive 2, then leave some space and write x plus 7 equals negative 2. Right, we have 2 options right here. That's what this plus or minus is telling us. Either one of those would solve the situation. So we want to subtract 7 from both sides. I didn't mean to highlight. And one of our solutions is x equals negative 5. And subtract 7 from this one. And the other is x equals negative 9. Either of these would satisfy the equation. And we can check it to see if it's true. Let's go ahead and do that. If I replace the x with negative 5, say, negative 5 plus 49. If I put this in my calculator, it will tell me that the answer is 4. So let's see, this is 25 minus 50 and 20 minus 70 plus 49. Let's see, 49 and 25 together, that's going to be 74. Minus 70 leaves us with 4. It works. And if we plugged in negative 9, we would get the same thing. Okay, let's repeat those steps on this one. Quantity squared equals number, so we take the square root of both sides, and we get x minus 3 equals plus or minus. If I simplify root 20, 20 divides into 4 and 5. 4 divides into 2 and 2. 2 things, I can take it out of the radical, right? So I've got 2 root 5. Now, because there's still a radical left here, the root 5 is not gone, I'm just going to leave it all together, but I do need to get x alone. So I'm going to move the 3. I'll add 3 to both sides, and I will get x equals 3 plus or minus 2 root 5. Okay, I hope this is helping. Maybe let's do example 5 all the way from beginning to end. We have x squared plus 16x minus 21 equals negative 5. I need to move this to the other side. So I'm going to add 21 to both sides. Now I have x squared plus 16x, leave some space, equals 16. What's my perfect factor going to be that I'm building here? Half of 16, right? So it's going to be adding 8. Then the number that I need in this place is 8 to the second power, or 64. I'll add 64 to both of those. Okay, so 16 plus 64 is 80. Now we can take the square root, both sides, and we get x plus 8 equals positive or negative. Let's see, 80 divides into 4 and 20. I think we could divide it by 16 maybe. Let me try that. 80 divided by 16 and 5, yeah. That's nice because square root of 16 is 4. So 4 root 5. Because we have this square root still part of it, I'm just going to leave that part like it is, but I do want x to be alone. So I'm going to subtract 8 from both sides. I'll get x equals negative 8 plus or minus 4 root 5. Okay. Solve by taking the square root. Okay, maybe let's do problem 5 together from the homework. On this one, I want to move the constant to the other side of the equation, so I'll add 45 to both sides. So we'll have 3x squared minus 6x equals 45. a needs to be 1, so I need to divide every single term by 3. So I'll have x squared minus 2x equals 9. Nope, 15. Sorry. 45 divided by 3 is 15. Okay. To build my perfect factor, I'm going to take half of that value, b value, so it's x minus 1. This number is negative 1 squared, so negative 1 times negative 1, which is 1. And I add it over here as well, 16. Take the square root of both sides. We get x minus 1 equals plus or minus 4. No radical, so write it in 2 ways. X minus 1 equals positive 4. X minus 1 equals negative 4. Then we can add 1 to both sides. And we found our 2 solutions. Okay. All right. Give these a try and let me know if you need some more help. Thanks.